Hello and welcome to example number 2 for lesson 1, position and displacement. This problem is more related to displacement than anything, and actually it's going to be illustrating the difference between displacement and distance. As we're going to be discussing in the lesson, displacement is just the difference in position of start and finish. So let's say that we took a trip to Red Deer, which is maybe 200 kilometers, less maybe, but about 200 kilometers, and we return back to Edmonton. Our displacement would be 0 because we ended up the same place we started. Now the distance that we traveled would be a different story. The distance we traveled would be the entire trip. We would drive there 200 kilometers, we would return 200 kilometers, we would add those values together, and we'd end up with a distance of 400 kilometers. All right, so let's show how we do that with a little bit of a visual aid for this example. Now, this example, it's trying to tell me I have a eraser tool on, but that's not true. Okay, this example, we are going to start with a brighter color and put down an origin, because I will read this in a sec. This says an object starts at a location 60 meters east of the origin. Well, I arbitrarily chose this point on my page to be the origin. I'm going to draw a little bit of a line over to here, and I am going to say that this distance from the origin is going to be 60 meters. Now, we haven't traveled this distance. If you read the question carefully, this is actually our start location. So at this point, we haven't traveled anywhere yet. You know what I should also do? I should put a compass on here, because displacement is, talking and writing is difficult. Displacement is a vector quantity, and which means its values have positive and negative values. So in this case, we're going to say that east is going to be our positive direction and west is going to be our negative direction. It's sort of a standard convention. All right, so now let's get into the problem. Let's choose blue here. And the question says that we're going to move to a location 40 meters west of the origin. Well, we're already 60 meters east of the origin. We're going to be moving all the way over here. All right, we want to end up 40 meters west of this origin. Well, to get there, we have to travel from our start location to that origin and then move past it another 40. So really, this is going to be 60 meters and 40 meters, and all together, we're going to be traveling 100 meters. All right, but the question's not done yet. The question then says, it finally moves to a location 25 meters east of the origin. Well, we're west of the origin now. We got to come back. We're going to come back to 25 meters east here. So let's get our line tool again. Let's choose another color, maybe magenta. And I'm going to say, okay, we're here now, but we want to end up probably somewhere in here. All right, and our origin is here. And so we're going to travel this 40 meters back to the origin and another 25 meters east. So this is 40 meters. This is 25 meters. The total distance we travel on this trip is 65 meters. And this gets us back to this 25 meters. See if we trace this up here. We could say that we are, in fact, east of the origin, and this is about 25 meters worth, right? This is about 25 meters here. Okay. Let's do some math now. We have our little bit of a diagram drawn out. Let's do the displacement. It gives us a formula for displacement. Okay, it tells us that the change in distance or displacement, change in distance is displacement, is equal to the distance final. So we have df minus, well, we could say, sorry, displacement final minus displacement initial. And that is going to come in here like this. So what did we start? We started at, sorry, I should say, what did we finish at? We finished at, final here, 25 meters east. So east being our positive value, we're going to say 25 meters. We're going to subtract our initial distance, which was 60. So minus 60 meters. And our displacement, our change in distance, works out to being, what is this going to be? Negative 35 meters. And since we're using east as our reference positive direction, this is negative 35 meters east. Well, what's the opposite of negative 35 meters east? Well, it's the same as, let's put this down here, same as a positive 35 meters west. Okay, so that's our displacement. Of the two, I'd say that's probably the more complicated answer. The second one just asks us to figure out the distance. Just straight up scalar value, no directions involved. So our distance, let's choose another color. Let's go with, what haven't we used yet? Green. So our distance. This is going to equal just the sum of all the places we traveled. So our first trip, we traveled 60 and 40 meters, so 100 meters. Then we traveled back another 65 meters. Our distance is equal to 165 meters. See, there's a bit of a difference here, right? Here, as we're traveling and coming back, we're going to essentially erase some of that distance we traveled. Distance, though, is just the full distance we travel. I'm going to give that a little bit of a box to indicate that it's my final answer. And end it at that.